We at Mcor Technologies developed a 3D printing technology called selective deposition lamination, or paper-based 3D printing.
So SDL is a very low-cost solution. It really makes 3D printing accessible for everybody. It's very easy to use, but it doesn't run on toxic chemicals like some of our competitors really rely. This is how the technology works. Mcor 3D printers include a piece of software called SliceIt. And what SliceIt does is that it takes in the digital file and it slices the model digitally, each layer equivalent to the thickness of a slice of paper. If you're printing in colour, you have two options. Either you get your file with your colour information on it, or if you don't have that, you can use another piece of software by Mcor called ColorIt, which enables you to apply colour to a regular STL or white file before sending it to SliceIt. Once the colour has been applied in ColorIt, you then import the model into SliceIt and prepare your model on the screen before you send it to the actual 3D printer. Printing in colour is a two-stage process. So when you have your colour model in SliceIt, when you hit generate layers, not only does it work out the cut profile around the geometry, it also works out the colour along that path. Then we hit print and we send that colour information to a 2D printer that takes the Mcor ink and prints that colour in duplex onto each sheet. We then take those sheets of paper and load them into a 3D printer for 3D printing. The process that we have invented is called selective deposition lamination, or SDL, and as the name suggests, we selectively deposit the adhesive. So what that means is that on the very first layer we apply adhesive, but in two different ways. On the waste material we put down a very low density adhesive, and on the part itself we put down a very high density adhesive. Then what happens is that a new sheet is pulled in from the paper tray. It's placed on top of the freshly applied adhesive. The whole plate is pressed up against a heat plate, which makes sure we have a positive bond between the two layers. The build plate comes down and it's ready for the next process. When the build plate returns to the build height, an adjustable tungsten carbide blade cuts just one layer at a time, tracing out the object that we're trying to make. When the cutting sequence is complete, the machine immediately starts to apply the next layer of adhesive. A new layer is pulled in, pressed together and cut, and the whole process is repeated over and over until all the layers are pulled into the machine. When all the layers are done, the part is finished and can be removed. The whole benefit of the SDL process becomes apparent when you actually try to remove the waste material from the finished object. Because we applied higher density adhesive for the part and lower density adhesive on the waste, it means that the waste material comes off very easy. Also, to make it easier to remove the waste material is cut up into cubes, or as we call it, dicing, which means that the waste material can be removed very easily into nice little blocks. And that means that you can get very intricate parts out of your model when it's finished. Unlike other technologies, Mcor 3D printed parts do not require dipping in toxic chemicals. The 3D printed object comes out very tough and very durable. If you want to make parts that can be drilled, tapped or water resistant, you can give them a quick dip and they're ready to go. Paper, as a build material, offers distinct advantages in terms of enabling wider, accessible, professional quality 3D printing. There is no more affordable, safe or colour-rich approach, and our SDL technology is suitable for any office, school, healthcare, laboratory or setting where people are learning, working or healing. This accessibility delivers what 3D printing has promised yet struggled to deliver for years: the ability for virtually everyone to improve the designs, shorten design cycles and win more business.